So this afternoon I'm going to have you phased, and the reason this is because we're going to talk boring and we're going to be talking about fuel pumps. So this morning we talked about governors and flyweights and how we repair and modify them to make them optimum again. And now I'm going to talk about phasing and what phasing is all about. The two parts of setting up a pump on a test bench is phasing and calibrating. Now calibrating is something that will go on another day, but it's getting the fuel quantity, the fuel flow correct for each cylinder. Phasing is how you get the start of the fuel injection correct for each cylinder. So let's take, for example, if we've got a 6-cylinder engine and we think of it doing a full revolution, we have to, on a 4-stroke, of course, in one revolution of the 4-stroke it's 3 cycles, but the pump runs at half engine speed. So the pump technically will do 6 injections for one full revolution. So if you imagine that as a circle, the actual revolution of the engine, and it's six equally divided points, we're going to be dividing it up into 60 degrees. So obviously 0, 60, 120, 180, 240, 300, and then obviously not 360, it's back to 0, which is your 360. So 1, 2, 3, 4, 5, 6. Right, so we now know that the start of injection for each cylinder needs to be at every 60 degrees, and that is what we call phasing. It's very, very important. Now, with modern systems, common rail engines and things, that's all done electronically. The ECU dictates, it knows the position of the crankshaft, and it does it that way. In this older technology, we install the fuel pump onto the engine at a set point where the first cylinder is going to fire, and then the others just follow suit because the pump has been correctly phased up in the first place. Okay, so how do we phase it up and why? Well, we know why. It's important to get them evenly spaced because we want that engine to be timed evenly on every cylinder. But how do we do it? How did the factory do it? And how do we do it to make life a little bit easier? Right, so how did the factory do it? So how it's assembled, how the actual the assembly is made. The camshaft is very much like a normal camshaft you'd get on running a valve train on a car. And it actually has these little roller followers. And these rollers are basically made up of the follower, like a little bar that it runs on, like a little axle, and then these actual rollers, which are ground and sized like a bearing. So they actually come in different sizes, which is quite interesting, it's quite fascinating. So when these are installed into a fuel pump, obviously we have 6 of these, and they go 1, 2, 3, 4, 5, 6, and they all run on the cam. Now, the delivery valves in this type of injection pump, they are just tightened down and sit on a shoulder. You can't adjust the height of the delivery valve like you can, well, when I say delivery valve, in some it actually lifts the barrel as well, and you can adjust the timing in that way, like on some certain other fuel pumps. These you can't. So you have to change that phasing, that timing, the point in which it closes the injection port, the inlet port, by either making this roller bigger or smaller so that it's lower or higher at a given point, or by shimming the actual barrel, which is what we've done by having some special shims made, because it makes the process much more straightforward. So from the factory, this is just some of the different rollers that you get. I mean, I've just measured these with a vernier. You can see, if you look at the measurements here, you can see the different sizes. We got 14.8 mil, 14.85, 14.97, and so on and so on. So we've got quite a variety of different rollers from the factory, which is interesting. And to see how the assembly is put together, we've got this, and then your element itself, which, like I was just describing, what I'll be showing you on the bench is the spill port cutoff. And the spill port cutoff is where fuel is being pushed into the inlet of the element body, into the cylinder, and as this element starts to rise, it'll only pump fuel once that hole is covered, because up until that point it can push it back out. So as soon as that hole is covered by the piston, a little bit like a two-stroke engine, that chamber is sealed and the only direction it can go is straight up. And obviously, like I've mentioned in my element video, the thing that stops it is by the port being open again by this cut. So as that cut then reopens that hole, it lets the pressure out and it stops the injection. So when phasing, it's very important, if you look on this element closely, you can see there's what some people call a retard slot, and it's actually just a small groove in the top of the element. I need to point at it with something to help you be able to see it. But this small groove here, and this helps to retard the timing. So mechanically kind of retarding the timing. So what we need to do is we need to make sure this element is rotated beyond that, because that will give us a false start of injection point. So if you actually get the data sheet out, the Bosch data sheet, which I can show you, it tells you a specific rack measurement. But we tend to go near full throttle, it gets it past that, and then you know you're in a good position. So the assembly goes together like this. The element sits in this, that slots in there nicely. The spring, which is obviously what pushes the whole assembly back down after the cams run round, and then it all sits in there like that. That goes up into the injector pump, and then the barrel comes down on top of it once it's in the actual in the body of the pump. Now, like I said to you before, the way that we can adjust it is bigger or smaller roller, which will lift or lower that, or shims underneath this, which will lift this up. But obviously you would have to take the lowest point and shim up from there. Right, so let me show you how that works and how we would shim one. I'll show you what the shims look like. These are the shims. They're very, very small. Very small. Look at that. That is the shim that goes underneath the barrel. So you would put a shim like that on the underneath of that barrel there. You'd hold it on with some grease, and that'll lift it up just enough to change that timing degree for you. So let me show you how that works. Okay, right, so we need the test bench on a pressurization cycle, so that it's actually forcing so much pressure into the pump, it's pushing the delivery valves open, and it's pushing the fuel right through, and we can see it come out of these return tubes. So we make sure we've got all those taps turned on so that we can bypass. It's not going to try and go through the test injectors to the glass. We're going to actually see it dripping right here on this tray. It's pretty old school technology, but this is what was created to calibrate these pumps. So although there are newer systems out, I really like this. Okay, so let's get started and I'll show you how it works. You can see I've just used something to lodge that rack forward, because obviously if we were back here, there'd be no fuel delivered. If we were here, we'd be into where that retardation slot is. So we're going to move it forward so we're well past that. We're going to get a true start of injection. As you can also notice, the flyweights aren't installed yet, and it's the flyweight which has the timing marking, and that timing mark is important because that's where we install it on the engine. So that is done using the position of #1 cylinder, which I'm about to show you. Right, so we will make sure we're switched on. Turn the bench on. So we're going to raise the pressure until we start seeing the delivery valves open. Delivery valves can start to open maybe sort of 5 bar, and we want to just see a nice steady flow of test fluid coming out of these. So if you want to come round back and look at these. So I'm going to just creep that pressure up a little, and you're going to see it start to come out there. There we go. So if you move closer, you can see a steady stream coming out of there. Now what's going to happen is, as I turn the injector pump over, as I rotate it clockwise, you will see as that element comes up, it's going to close the inlet hole and it's going to stop the fluid pouring out. And that is called spill port cut-off. And at that very point is the start of injection. So let's find number 1 first and we'll go from there. So if you come around here, we have a look, and you can see them moving. You can see, I'll go backwards a bit there, but if I move it clockwise, you'll see it start to move up, this number 1. And then as soon as it starts to move up, we need to be looking here. We know that it's about to stop, so there you go, you can see it stopped. Right, so the important thing there is, I've not quite clocked the pump on the bench right, but I can still show you this. I'll back that off, and you need to be very, very, very sure that as you're gently turning that you get it so it's when it's just stopped. Because if you go past that or anything like that, you know you're going to end up with some inaccuracy, which is going to throw your results. So, there we go, it's just stopped. Right. So then, I'm going to move my 0 point of my bench around so the 2 zeros align. So there, I've moved my 0 point round so that my 2 points align. This part moves, and this part stays stationary, and this part moves with the pump. And you can see, if you move closely, you can see the 2 zeros aligned. Okay? So, the firing order for a 6-cylinder, if you didn't know, 153624. That's the standard firing order for your 6-cylinder injector pumps. So, we've just found out where number 1 is cutting off, and we've marked it at 0. So if everything was perfect, number 5 should cut off at exactly 60. And that is what we're going to find out next. So I'll turn this pressure back on. Wait for it to come through. Okay, so next we're going to be looking out for number 5. So if you count across 1, 2, 3, 4, 5, this one here should start to close at 60 degrees. Right, so I'm going to start moving it round. I'll tell you when we're getting close. 5, just starting to move now. Just coming round. Oh, it's already stopped and I missed it. Let's go back. Okay, it's just stopped there. Right. So if you look here, the actual 60 mark, if you can look closely, if you can zoom in on that, you can see the 60 mark isn't quite aligned with the 0. So we have an inaccuracy, and if we look at this here, each one of these lines is a degree. So we can see that number 5 is cutting off a degree too early. So we need to make that cut off a degree later, because it's cutting off at 59 degrees instead of 60. So to make that cut off later, what we'll do is we'll literally raise the barrel with a shim, and by lifting that barrel away, it takes more rotation to physically get it to cut off, and then we get the 60 degrees that we want. Now, we could change the rollers, like I mentioned, like the wood sort from the factory, but to change those rollers, you would physically have to, which again is totally feasible, totally possible. You can write, and this is the way that I used to do it, you can write all the numbers down. So what we'd do is, for this one, we'd put 1, 5, 3, 6, 2, 4, that's your firing order. So 1 we'd put at 0, 5 we'd put at 59, and then we'd do 3, 6, 2, 4, and we'd measure them all and find out where they are. And then from that, if you know your rollers and what size makes what difference, you would then change them accordingly and keep doing that backwards and forwards until you got it right. It's quite labour intensive. You've got to pull the cam out. You've got to do a lot of labour to do it. Anyway, so I'm going to go through these, which you might want to fast forward, but we'll do all of them, 1, 5, 3, 6, 2, 4, find out where they are, and then we're going to pull them, shim them, and then show you what difference it makes to get it phased. you can see here, this is what I've just measured. So the targets would have been, as I mentioned before, 0, 60, 120, 180, 240 and 300. So 0, yes, of course, was right because that's where we started. 59, so 1 degree behind. 119, so 1 degree behind again. 179, another 1 degree behind. Bang on 240 on 2, 1 degree behind at cylinder number 4, 300. So what we're going to do is we're going to shim the barrels on the ones that are behind to lift them so that they take more of a revolution to actually spill pour cut off. So we're going to shim 5, 3, 6 and 4. So we're going to put shims in those 4. And then we're going to test it again. We're going to mark on 5, we're going to mark on 3, mark on 6 and 4. 5, 3, 6, 4. Now, when it comes to retesting it, don't be tempted to try and put your injector lines. By the way, these are hard lines. A lot of people have reported that these are soft, and they are not. They are hard lines. So I'm just going to get my camera assistant to come back in and help with the camera. Don't be tempted to try and tighten your injector lines, your hard injector lines, down to your delivery valve holders unless you have the retainers in place, because if you rotate them it can change how far they push down and it can mess things up. So just take the time to put the retainers back on. Okay, so we're going to just slip them over there. It's really straightforward. You might be using this video to help install your very own Diesel Pump UK fuel pump builder kit on your test bench, and that's kind of why I did this, to make it a little bit easier for you guys out there that have never touched one of these Bosch M pumps before. It's all basic stuff. It's just a lot of the stuff is not available to help you build them anymore. Right, so they're all torqued down nicely. Just the retainer bolts for the bolts for the retainers. Right, so we're going to put these hard lines back on. A lot of people think, or I've mentioned in my videos before, how come you're using rubber lines? They're not rubber lines. These are solid steel hard lines, and this is insulation to keep the warmth in. That's like your Rolls-Royce of injector testing line, I'll have you know. They're not rubber lines. The rack's in the forward position. We're going to close that off to make sure that we get fuel pressure. Start up the pump. Also worth noting that on this stage, you can take the lift pump cover off. And if you have any leakage that's coming past the elements, you can see it at this point with that high pressure. For some reason that bulb will not come off. That thing normally spin off with the fingers. So you can see that that's not filling up with diesel inside here. That's some oil from test oil and some test fluid from when I pulled them up. But if you had that overflowing, you'd know that you had a leak coming down from the elements. You'll find that if you ever do get, something like a poor quality element, you can find that, diesel gets into your oil. So, okay, we're going to do the test. We're going to roll it back round to 0 to make sure the reference point's in the right place, and then we're going to go from there. So, we need to increase the pressure. Yeah, we can see it coming out there. Same as before. We're going to roll it round until we get number 1 lifting. Number 1's just starting to lift now. So we're going to bring it until it just cuts off. Do that again. There we go, just cut off. Yeah, we're sat on 0 there, which is nice. You can see it there, look. We're starting on 0, just as we did last time. And then we're going to run through the process exactly like we did before. First, next one, 1, 3, 1, 6, 1. I've completely forgotten. The firing order of 600 engine. 1, 5, 3, 6, 2, 4. Right, so going on to 5. So there we go, 5's cut off. And look now, before we were before, and now we're bang on the mark. We're bang on 60 degrees with the shim in there on number 5. So we're going to roll it round, 1, 5, 3. So, to 120 degrees, and that'll give us cylinder number 3. There's the spill port cut off of 3. Go back to right. Ooh, 3 is like pretty much bang on as well. Look. So 3, we've just spill port closed it. If anything, it's just over. It's not even a degree. If you line it up with this, it's not even a degree off. We're talking like 0.1 of a degree off, which I'm quite happy with. So moving on to 6. So 300 basically bang on. I'm really happy with that. We've got spill port cut off on 4. Pretty much there, bang on. So to conclude there, what we've done, we shimmed the 4 with the shims, and that saved us having to physically take that camshaft out and totally change all the rollers, thus disturbing everything. The shims are made to an amazingly good tolerance, so they're tried and tested. So there we go. That's basically the process, what's involved in phasing. Sometimes it's not quite as straightforward as that. Sometimes you've got to go backwards and forwards, you might have to change more than one shim, you might have to put 1, 2, you know, you might have to play about a little bit. But that gives you an idea of what goes into phasing it to make sure that it's firing it evenly every 60 degrees if it's 6, or every 72 if it's 5, etc, etc. So the next step, I suppose we could show the calibration, but we're not going to do that today. We're going to show you that on another pump another day, because I have to get some work done now. So enjoy, guys, and I hope this made sense.